Hi, I'm Kim from Captis Aire, my spin-out company. I'm excited to share with you today my presentation, which is on emissions control. I'm specifically going to be focusing on reducing greenhouse gas intensity by using an alternative emissions control device that uses activated carbon to very efficiently adsorb the emissions in a fluidized bed concentrator, the FBC. So we've all seen the news, the fires in California, hurricanes, and more. There are plenty of reputable agencies that have documented the effects of climate change. In this particular example, I'm quoting NASA, who talks about how temperatures will continue to rise. There will be changes in precipitation patterns, more droughts and heat waves, that hurricanes will become stronger and more intense, and sea levels will rise, impacting where our communities can live and work. And there could be impacts on agricultural yields. So while there are questions about what's causing climate change, one thing we know for sure is that the concentration of greenhouse gases in our atmosphere have continued to rise over time. Most recently, they've been documented over 400 ppm. Now, greenhouse gases actually serve a useful purpose for us in our atmosphere. They keep our average surface temperature at a nice, comfortable 60 degrees Fahrenheit, as opposed to a chilly 0. But one thing that we can do to continue to impact the amount of greenhouse gases in our atmosphere is work to reduce the amount of greenhouse gases that we release. And one of the ways that we can do this is by our choice of an emissions control device. So the problem with emissions control devices today is they rely primarily on a technology called oxidation. This means they heat the air to very high temperatures to burn up the emissions. This creates greenhouse gas emissions in 3 ways. First of all, by oxidizing the very emissions they're controlling. Second of all, by using natural gas to heat the air. And third, by using electricity to run the device. So the alternative is to very efficiently adsorb the emissions at the temperature that the air comes out of the process. So we create a lot less greenhouse gas emissions. And by adsorbing rather than oxidizing, we have the opportunity to transform what would have been pollutants into valuable byproducts. So what that means in the wood industry is that when you dry wood, especially pine wood, the primary component of those emissions are terpenes. So when we recover those emissions, we're recovering these valuable terpenes as opposed to burning them as a waste, as happens today. So the great thing about the FBC technology is that it's already commercialized in many applications, such as automotive and electronics manufacturing. In this particular example, they're using it to control the emissions from painting cars in the automotive industry. Here you can see that Honda Motors of Alabama was honored as Air Conservationist of the Year when they implemented the FBC to control emissions when they increased production. So the FBC is only new to the wood drying application. And for that application, Georgia-Pacific Chemical has already filed 2 patent applications. We've been investigating the use of the FBC for controlling emissions from wood drying since 2015. Since then, we've run 2 very successful pilot unit trials at a commercial wood drying facility, one in 2017 and one in 2018. In 2018, we were online for over 1,700 hours, over 6 months. One of the most important things that we did as part of these pilot unit trials was measure the emissions reduction capability. Near the end of the 2018 pilot, we ran 2 testing events. We used 2 separate, independent, certified air emission stack testing companies, One was Aire, that's Advanced Industrial Resources. The other was John Zinc Hamworthy Combustion. In both of these testing events, we demonstrated the ability to control the VOC emissions by over 90%. And this is important because it meets the MACT PCWP standard. We also controlled HAPs, that's formaldehyde and methanol. We reduced these by 75 to 85%. And we controlled particulates at 50 to 65%. We then took these results and calculated the total potential emissions in pounds per hour that would have been released by both the FBC and the RTO. That's the Regenerative Thermal Oxidizer. What this chart on the right clearly demonstrates is that when you compare the difference in potential emissions released by these two devices, the single biggest difference was the reduction in greenhouse gas emissions in pounds per hour. You can also see that the difference in potential emissions of the rest of the pollutants was relatively small. So our next step to commercializing this technology is to scale up to a full-size commercial system. To do that, we have to be able to permit this device. In preparation for permitting, we've had 2 discussions with 2 state agencies and with 2 experts from the EPA. In every discussion, environmental agency personnel were supportive of permitting for a full-size commercial system. It's also very important to understand that while this particular emissions profile is probably different than what any single manufacturer has in their permits today, in speaking with agency personnel, they said that in light of the reduction in greenhouse gas emissions and the recovery of a valuable byproduct, they would happily accept these trade-offs. So this slide demonstrates the factors that enable us to drive down the greenhouse gas intensity. Here you can see we used no natural gas, and we reduced electricity usage by over 40%. Finally, we adsorbed rather than oxidized the emissions. So these 3 factors were what enabled us to drive down greenhouse intensity by over 80%. So this map shows some of the many potential sites where we could utilize this technology to drive down greenhouse gas intensity. Right now, we're focusing on the wood drying segment, specifically wood pellets, oriented strand boards, and plywood manufacturing, which are shown on this map. But there are plenty of other potential applications for this technology. For instance, there are over 100 segments of the chemical industry that are subject to the Clean Air Act that could utilize this technology. Beyond that, there's the energy sector, specifically coal mining. Finally, there could be applications in agriculture. So the point is, there are many potential sites and potential applications where this technology could be utilized to drive down greenhouse gas intensity. So our pilot trials were very successful. We reduced greenhouse gas intensity by over 80%. We reduced VOC emissions by over 90%, which is important because it meets the PCWP MACT standard. We collected terpenes, and we demonstrated good operational reliability and safety. Our final step to commercialization is to scale up to a full-size commercial unit. We're talking with a number of wood drying prospects today and look forward to taking this final step. I'd like to acknowledge Georgia Pacific Chemicals, our patent owner, from whom we will be licensing this technology, as well as our partner, Environmental CNC. HAL and Environmental CNC have been fantastic partners with us every step of the way since 2015. They've already demonstrated the ability to commercialize this technology outside of wood drying at over 60 sites worldwide. They've overseen fabrication, installation, commissioning, and operation of these devices. This team has the necessary capabilities integrity, and passion to deliver. If you have any questions at all for me about how these emissions were measured or how we calculated these emissions improvements, please reach out to me to learn more. We're very excited and happy to share. Thank you so much for your time. Thank you.